Hello, this video is going to be a video tutorial of how to run an item response theory model or IRT model for polytomous, ordinal polytomous data. I will also go over how to run differential item functioning for polytomous data as well. Now, ordinal polytomous data, this is basically data that are ordered, that have multiple categories that are ordered in some way. You typically find these sort of instruments in like the medical or psychiatric field, but also satisfaction surveys typically have them as well. Now, why do you even want to do this? Because you might ask yourself this because I've previously shown how to run IRT models for dichotomous data, and you might think, well, maybe I can just dichotomize, items with or a scale that has multiple levels or categories. You can just put them into two groups, which like low or high. Now, the reason why you may not want to is because it's been shown that you can actually get more test information from having additional levels in the scale. In addition, what that really means is that you can better estimate ability, which is effectively what you're trying to do with an IRT model, using additional levels. Not only that, you can actually do it with fewer items as well. So you can more efficiently do it if you're using or incorporating ordinal polytomous data. Now, the specific IRT model that I'll be using is the GRM or greater response model. But first, let's go over the actual data set that I'll be using throughout this example. The data set is the Generic Conspiracist Beliefs Scale. This is the response data set was found in openpsychometrics.org. Now, basically, it's a 15 item scale with 5 levels, one being strongly disagree, all the way up to 5, meaning strongly agree with each of the items. Now, these items they're trying to measure the construct of conspiracy theory beliefs, and it's a lot of the items are associated with things we typically expect, to see from people who hold these conspiracy theory beliefs. Now, the first step is I downloaded the data onto my desktop. It's a CSV file. And the next step is what I already did was I loaded it into my global environment. I used the read.csv file function and then file.choose to locate the file. So now it's loaded into my global environment and it's called GCBS, and you can also see it on the right. Currently there's 2,495 examinees in the sample. Now, first I want to just do a little bit of data cleaning and data set because a lot of questions were asked and only the first 15 items are related to the actual instrument. So I'm going to take a subset. I'm going to select, I use a subset function on the data set, and I'm interested later for the differential item functioning in a group, so I'm going to use gender. So I'm going to basically select anyone who's indicated 1 or 2, which is male and female respectively, and I'm going to select just the first 15 questions, 1 through 15, and I'm also going to select gender. I want that to be thrown in. So now this new data set will have in total 16 columns. So I also want to do a little bit more data cleaning, as I noticed there was some values were missing, and it was missing by 0. Each value is going to be, for the items, is going to be 1 through 5, but I noticed zeros also meant missing. So I'm going to set zeros equal to, anything is equal to 0 in the data set. I'm going to set it to NA. Then what I'm going to do is I'm going to remove anything that's NA right here. Now let's get ready for the analysis. The GRM IRT model, you would have to basically download the LTM package. I already installed, you use install.package to find it, and basically I'm just going to call it right now. So it's basically the GRM model is a unidimensional IRT model for ordinal polytomous data. And the first thing I'm going to do, the function is basically just GRM and the actual data set. And here what I'm indicating, the data set, I'm saying just use the first 15 columns, comma 1:15, that's what it's indicating. And I'm going to use the constrained version. Basically, I'm going to set the discrimination parameter to be constant across items. And now I'm going to fit just the constrained model. The constrained equal true, that's what it's indicating. So I'm going to run it. And we're going to take a look. So in the bottom right here is going to be the output. So let's scroll up. So these are the coefficients. So as you can see, all the way on the right is the discrimination parameter. Because I said constraint is equal to true, it's basically constant across all the 15 items. Now for the parameters on the left is the extremity parameters. The first extremity parameter, it's basically telling you the level of ability or theta, or actually more specifically the level of conspiracy theory beliefs in this case. For the conspiracy theory belief, the level of -1.292, there's a 50% chance of selecting the option 1, basically, which is the strongly disagree. Extremity parameter 2, -0.722, is the ability level or the conspiracy theory belief level that is there for having a 50-50 chance of selecting the value of 1 or 2. And this is, and so on for extremity parameter 3 and 4. Extremity parameter 4 being the ability level or the conspiracy theory belief level is 0.553. That's the ability level for having a 50-50 chance of selecting the options 1, 2, 3, or 4. Okay, that's all it's showing. Now, we can also run the non-constrained version of the GRM model, but this time, and you don't have to set anything, so already assumed to be false. You have to actually set it to be true. So to run the non-constrained model, you just do GRM and indicate the actual data set. Yeah, that's my dogs in the background. I don't know if you can hear them. But yeah, they're a bit distracting, but it just takes a quick second to run. And so here we go. So let's scroll the way up, and you can see it's the same as before, but this time the discrimination, well, it's not the same as before. The interpretation of the extremity parameters are the same as before, but this time the discrimination parameters are different across different items. Now you might also want to actually check which model is better, the best to use, the constrained or non-constrained version, and you can use the ANOVA function likelihood ratio test to do this. So let's actually run this whole thing, and it's significant. This means that it's best to just, you can pretty much just use the constrained version. that it showed an improvement in fit. So now, meaning from now on, I'm just going to use Model 2, the constrained version. Model 2 is the non-constrained version. Basically, the results, likelihood ratio test showed that the non-constrained version had showed a significant improvement. So from now on, I'm just going to use the non-constrained version, meaning I'm letting the discrimination parameter vary across items. And that's what I did for Mod 2, the Model 2, which indicates the GRM model. So the next thing you might want to do is run or plot the item response characteristic curve for each item using the plot function and the name of the model, the name of the specific GRM model, which in this case is Mod 2. So I'm going to run this, but first what I'm going to do is actually just decrease the size of this just to make it easier to view on the right hand side. And now I'm going to just run, and what's going to ask me in the bottom is to just hit enter for every plot that I want to pull. So let's just take a quick look at this. This is the item response characteristic curve. Let's zoom right in here. And what it's showing here is for item 1, the response category, all 5 response categories. On the horizontal axis first is ability, which in this case the construct being measured is conspiracy theory beliefs. And the vertical axis is the probability of endorsing a higher response on the scale. So here, category number 5 most resembles the ICC item characteristic curve, S-curve, in the typical traditional dichotomous response data set, in that it's a monotone increasing function. The category 5 means strongly agree, and category 1 is a monotone decreasing function, and it represents strongly disagree. Meaning that for going back to category 5, as ability, or in this case conspiracy theory beliefs, increases, you would also expect the probability of endorsing a higher response on the scale it also goes up. The opposite is true is for 1, and for all the intermediary response categories, they go up until a certain point, but then they, like for in this case number 4, but it goes down for the really high end, or I should say the higher levels of the construct being assessed. So let's go back. So just running this, basically have to hit enter a few times, and it'll show us the IRCC for each item, and we can, at any point zoom. Now the next plot we might be interested in is the test information function, and you can do this same plot function, but this time enter type is equal to IIC and items is equal to 0. Let's run this. Let's see what it looks like. And here you can see that the test information function ability, it's for the most part, it's normally distributed. It's not leaning more towards one end of ability versus the other. And you can actually look at item-specific information function if you indicate the specific items you're interested in. = 0 will give you the entire test information function, but you can also look, I'm sorry, you can actually look at the specific items if you're interested in as well. Now the next thing, you can also plot all the items, item information function for each item all together on the plot. And what this is showing, it's the item information function. And right off the bat, I see you can look at number 10 here in the red, and you can see it's not providing a lot of information. So give you a sense of which items, are either leaning towards a higher end of ability or leaning towards a lower end ability, or not giving enough information at all. So, and that's what it shows. And you can also like pulled a list of the estimated abilities that were produced by the GRM model for each examinee using the function factor dot scores. And usually ability will range, for the most part, between -3 and 3. Theta is another word for ability. I think I said that already, but I just want to make sure I don't want to confuse. I don't want to confuse anyone. I might be going back and forth. So, but let's run factor dot scores first. And then let's pull up and look at the ability estimates for only the first 10 examinees. So the ability estimate in this case is Z1. So let's run it. And you can see for the first 10 examinees, they're all on the lower end because it's indicative based on the negative numbers. So that was the GRM model. So now let's get into detecting differential item functioning, and this time we're going to be using the lordif package. So let's load the package first. Now let's clear this because we don't necessarily, at this point, let's clear the plots. I just selected the broomstick. Now, what differential item functioning is, I have a separate video on this, but I used dichotomous data. This time I'm using polytomous data, and this lordif function, lordif package, it basically allows for the use of polytomous data. Now, what it uses is a combination of the ordinal logistic regression combined with IRT, meaning that it's not like the previous dichotomous data DIF item detection methods using logistic regression. They typically focus on sum of total test scores and not ability estimates via the IRT models, like IRT models that are used. This time, for this approach though, it's actually combining both, so it's actually using ability estimates along with the logistic regression, the ordinal logistic regression. And basically, to detect the diff items, but also let me just describe what diff items are. It's basically items that for examinees of the same ability, for some reason, different groups have a different probability of endorsing a specific items, even though they're detected to have the same ability. And basically this is just detecting those specific items. And right here, it's to run this, it's the lordif function. You just enter the name of the data set you use, which is the first 15 items of the conspiracy theory beliefs scale. And this right over here is the vector containing the grouping gender variable. And the criterion I'm using is the chi-square. It's the likelihood ratio test. And this is basically right over here, the cutoff that I'm using, alpha 0.01. So let's run it. So this right here, it uses the iterative approach and involves re-estimating parameters on subsets of the data based on a group, and it detects diff again, and this is repeated until the same items are detected as diff twice in a row. So, but let's actually scroll back up, and this was the iterations. And the reason why you use some sort of iterative method or purification technique like this is because that the presence of a diff item actually might impact another item being detected as diff as well when it isn't really a diff item. So you have to use some sort of method to purify the data set. And here it detected about like 12 items initially, and after a couple of iterations, after the next iteration, it detected 11, and it was found again, so the iteration stopped. So looking at this, just to remind, we're using two groups, male and female, and it found 11 out of 15. So the majority of items were flagged as diff. And it's telling you right here all the items are flagged as diff. And the number of iteration, the detection criterion, and the threshold used. So here are the results. So for each item, NCAT is the number of categories per item. This technique also can like reduce if like there were some categories not selected pretty often, you can look through it and check to see if that's the case or not. What this does is it can sometimes collapse it, but in this case, it shows that none of them, all 5 categories were included. Meaning, what I mean by collapse is like sometimes a category might not be pretty much selected too often on a scale. Maybe it's higher end or lower end. It sort of tries to collapse it in some way, and you can actually set a criterion in this function as well that you can use, like a min cell count. It offers that feature. So there are 3 nested logistic regression analyses models that are ran, and the chi-square test compares each pair of these 3 tests. So the first column compares the model 1 and model 2. This looks at the uniform, tries to detect uniform diff. The second column detects both uniform and non-uniform, and the third column, which compares models 2 and 3, it tries to detect just the non-uniform. So what is uniform versus non-uniform diff? Uniform diff is when the diff effect is pretty much, uniform diff is when it's constant across levels of ability. Non-uniform is when it varies across levels of ability. And this is what each one of the tests tries to compare. And an item is flagged as a diff item as long as one of these tests is shown to be significant. And that's why here in this case, all these items were flagged. So the first item being question 2, and you can see both comparison between model 1 and 3 and model 2 and 3 were flagged as significant in this case for item 2, and that's why it was flagged. Now that we've detected the diff, you might also want to actually look at the plot. So let's first thing, let me minimize this size just a little bit again, because the next series of plots, 1, 2, and 3, and now I'm going to run it. It's going to show a number of plots. It takes a few seconds to run, and now let me scroll to the first plot by hitting this previous plot arrow, and I just want to start from the beginning, and right here it's going to be item 2 with the first diff item detected, or actually this trait distribution. Okay, so the graph here shows the distribution of theta, or conspiracy theory beliefs. You can see for the most part that the distribution is the same between males and females, but females showed slightly higher levels of conspiracy beliefs, which is kind of surprising. So now let's look at the next plot. Now, for the first diff item detected, item 2, the 4 tables are produced. The top left table shows the ICC, or item characteristic curve, by gender for item 2. The horizontal axis shows the level of conspiracy belief, and vertical axis shows response category. So as someone selects a higher response, the level of theta is higher, and you see there is some space between the male and female lines here, the solid and dotted line. The table to the top right, the top right next to it, right over here, it shows these 2 little bumps, it sort of shows, they further highlight the discrepancy between gender on the theta level right here shown on the left, showing these two bumps indicating where this discrepancy exists on theta. And you can actually, on this, the bottom right over here, it shows you can look at this as it's the absolute difference of what exists on the top right over here. Now, yeah, I'm a little bit all over the place, but going back over here is the item response item response characteristic curve. It's you can also call it the item response function. I described it before, but this time it's disaggregated or disaggregated by gender, male being the solid line and the dotted line being female as well. And it does this for each one of the items detected as diff. Now, so right over here is the test characteristic curve for all the items together on the left, and on the right it's only the diff items. So right off the bat you just see that for the most part it's very similar. It's pretty much almost exact between male and female. So when you aggregate or pull in all the entire test together, there really doesn't show much difference between male and female using all the items together. Now this plot over here. So these two tables, they show differences. Both of them show differences between theta or conspiracy theory belief, or more specific, theta scores that pretty much do not account for differential item functioning. The difference between like the initial score that doesn't account for it, and like the diff score after, or I'm sorry, the theta score after accounting for diff. So the table on the left is a box and whisker plot which shows the median difference, which is theta here, and the interquartile range. And the interquartile range, for the most part, the median is the line and the interquartile range is the box. Now the table on the right, this shows the initial theta on the horizontal axis right over here, and the difference in theta on the vertical axis, the difference between the not accounting for diff, between not accounting for diff and after accounting for diff. So you can see that those with, like, just by looking over here just at the left side first, less than 0, you can see that those with lower initial theta or conspiracy theory beliefs less than 0, that taking diff items into consideration for that initial lower end group right over here, there led to higher scores for females and lower scores for males. The triangles representing females and the circles representing males. And the opposite is true of this other end between 0 and 2. You can see that taken into consideration, the diff items led to higher scores for males and lower scores from females. So the difference were inconsistent between genders when considering diff items. So it did show an impact. Now, yeah, and that's pretty much what the package does. But one last thing to consider is that we did detect a lot of diff items. So what do you do after you've detected diff items, or if you detected a lot of diff items? And one option, prior research has shown that one option is to potentially, you might even want to use separate scales for these individual groups if there's a large number of items, and for example, like 50% of the items are detected for having detected as diff items, and this was suggested by Bolt et al. In 2004. But so yeah, I went over some of the, I think I hit on a few things. I just wanted to run through everything that I can think of at this point. But let me know if you have any questions, or if you have any additional different types of analyses you want me to cover. Thank you for sitting through the end of this video. I hope I wasn't a little bit too all over the place, but thank you a lot.